Hello everyone, hope you all are doing well. So in this video, we'll discuss the third problem of Leetcode BiWeekly contest 115. It's a medium one and yeah, it's following a very, I would say, popular pattern. We'll see what. Let's start with the problem statement first and then we'll, do it together, right? How to approach the problem and all, right? So the problem statement says that you are given an integer n, a zero indexed string array words and a zero indexed array groups. Both arrays have length n. Okay. Now the Hamming distance between two strings of equal length is the number of positions at which the corresponding characters are different. Okay. You need to select the longest subsequence from an array of indices. So you have indices from 0 to n minus 1. You have to select longest subsequence of indices such that for the subsequence denoted as this I0, I1 dot till ik minus 1 having length k, the following holds. Okay. What are the conditions? For adjacent indices in the subsequence, their corresponding groups are unequal. That is, group of this element should not be equal to group of the next element that is there, right? Group of I of j should not be equal to group of I of j plus 1. For each j lying between 0 to k. Simple. No two adjacent elements that you have selected should have the same group id. What is the next condition? Words of ij and words of ij plus 1 are equal in length and the Hamming distance between them is 1. Again, the indices lie between this. For all the indices in the subsequence, right? I know it's a big problem statement. I'll explain it again. First, we are going through, what it dictates, right? Return a string array containing the words corresponding to the indices in order in the selected subsequence. If there are multiple answers, return any of them. Remember, if there are multiple answers, return any one of them. This makes the problem very easy. They could have made the problem tough by asking that, okay, if you have multiple possible answers, probably return the lexicographically largest possible combination or lexicographically smallest possible combination. That would have been a better version of this. But yeah, that's none of the case, right? We'll discuss this one only. Okay. Now what's the subsequence? The subsequence of an array is a new array that is formed from the original array by deleting some, possibly none of the elements without disturbing the relative positions of the remaining element. Note, string in words may be unequal in length, right? Big problem statement. Let's directly jump to the example to understand it better and get a feel of what the problem is saying. Okay. So the problem says you have three words. This is the array words 1, 2, 3, and the groups for these corresponding words is 1, 2, 2. That means this lies in group 1, this is in group 2, this is in group 2. Okay. Now what we have to do? Out of these three elements, try to select as many elements as possible. So that is why it says longest subsequence from this array, right? Now, how there will be some condition to select the elements, right? What is that condition? So suppose out of n elements, you have selected some element. Let's call it 1, 2, 3. These are the three elements that you have selected. Suppose you had 5 elements, you have selected 3 elements. So you need to follow two conditions. What are those two conditions? Whatever elements that you have selected, remember this is a subsequence, right? So you do not reorder the elements. It's just that you delete some elements from the original array to get a subsequence, right? So what I mean to say, if 1, 2, 3, 4, 5 were the original 5 elements, maybe you delete this one and this one. So what do you get? You get 1, 2, 4. So these are the three indices that you have selected. Now what's the condition? For any two adjacent indices, their group ID should not be equal. Okay, it should be unequal and their Hamming distance should be equals to 1. Remember, the Hamming distance is calculated only when the length of the string of this one and this one is equal, right? Okay, these are the only two conditions, my friends, that you need to follow. And you have to tell the longest common, subsequence that you can select from this array, right? Like for example, in this case, you have three words, BAB, DAB, CAB. Okay, and what do you have to do? You have to try to select most number of elements. So let's first make the problem simple. Suppose I select BAB, right? So I can select BAB and DAB. Second option, I can select BAB and CAB, right? Remember, I cannot select this guy and this guy. Why? Because their group IDs are same. Okay, that's why. Okay, and obviously they will be consecutive, right? If you select these two, they will be consecutive in the subsequence as well. If there is an element in between them, there is no issue. You can select probably this one, and an element between it, right? But here it is not possible, right? Now these are the two possible combinations you can select. Let's calculate the Hamming distance. So here just one position is different, these two are same. Similarly here also just one position is different, these two are same. So that means you can get two possible combinations of length 2 and both of them are valid. So select any one of them, right? So this is BAB, getting it? So this is how you select it. That is why this is the answer, right? Let's see this one. You have 4 words. This one is in group 1, group 2, group 3, group 4, right? This one is an easy example, right? So what you can do, you can select this one, and with this you can also select this, right? Why? Because the group IDs are different, the Hamming distance is 1. Similarly you can select these two as well, so that means you can select all the 4 elements, right? And all the consecutive elements are following the condition. Whatever you want, that is being followed, hence why ABCD is your answer, right? This is the problem statement. You just need to consider 2 conditions, right? Okay, the number of words that you can have is 1000. Each word can have a length of 10, and obviously each word can lie in different groups. So at max we can have n groups. Words consist of distinct strings. Words of I consist of lowercase English characters, right? That's it. Now let's come to the basics, right? What could be one of the possible ways? One of the possible ways could be, I have some words, right? These are some words that I have, right? Now if I have n words will have how many possibilities? So for the first word, I can select it, reject it, select it, reject it, select it, reject it, select it, reject it. So 2 possibilities for everything. That means for n words, I can generate 2 raised to n subsets, or rather, sorry, in this case, subsequences, right? I can generate 2 raised to n subsequences, and then we can check that, okay, whether a particular subsequence is valid or not. If that is valid, what is the subsequence with the maximum length, right? This is the brute force approach, right? But the number of words that you can have is 2 raised to power 1000. So obviously this will not work, right? This will not work. So now let's come to the second approach, right? So forget about this problem. Maybe most of you, like if you are familiar with dynamic programming, or you must have heard about a problem where you have to find the longest increasing subsequence, right? Longest increasing subsequence. So there we follow a very beautiful approach. Okay, what is the approach we follow? Suppose you have some elements, right? Now you want to find the longest increasing subsequence. Okay, so what I'm trying to do here is, we are picking up a very popular problem and we are trying to relate that popular problem and its corresponding solution to this problem. Okay, we are trying to reduce it. Okay, so these are some words, right? You want to find the longest subsequence. So in this case, what we do, right? Suppose I take the elements 1, 2, let's take 2, 4, 3, something like this. Okay, so what's the longest common subsequence in this one? You can pick 1, 2, and 3. Right? Longest increasing subsequence. My mistake. I'm always saying longest common. It's longest increasing, right? So in this case, what you do, you go to every element. And you say that, okay, suppose this is index number 0, 1, 2, 3, 4. If you come here, you say that, okay, find the longest increasing subsequence which is ending here, right? This is the approach. So how we do that? So suppose I want to find the longest increasing subsequence which is ending here. So what I'll do, I'll traverse from index number 0. I'll just see that is 1 less than 4. Yes, that means I can generate a subsequence which is ending at 1. I don't know what are the elements before it, but which is ending at 1, and after that I can have 4. All right. Similarly, 2 is also less than 4. So that means I can have a subsequence which is ending at 2. Why I am saying ending at 2? Because for every position, I'm keeping a track of what is the length of the subsequence ending here, right? Like for example, when I start from 1, there is no element before it. So the length will be 1. I mean, there is only one element I can have in the subsequence which ends here, right? If I come to 2, what happens? Look, there is one subsequence which ends here, right? You can just take the single element. What are the other options? Now before this 2, I have a 1. Is 1 less than 2? Yes, 1 is less than 2. So that means whatever is the subsequence which ends at 1, that subsequence If I add 2 in that subsequence, my length will increase by 1. Okay, so my length becomes 2. The maximum length becomes 2. Again I come here, right? So by default, obviously the length will be 1. You just take single element. Now, is 1 less than 2? Yes. So what's the maximum length ending here? It's 1 plus include this element, it becomes 2. Is 2 less than 2? No. So no updation. Similarly, when you come to 4, you just see, is 1 less than 4? Yes. Okay, what's the maximum length of subsequence ending at 1? It's 1. So 1 plus 1, it becomes 2. Why 1 plus 1? Because length till here is 1, you add one more element. Now, is this 2 less than 4? Yes. Okay, what's the maximum length ending at 2? It's 2. 2 plus 1, this element, it becomes 3. So that means the maximum, the length of the longest increasing subsequence ending at 4 is 1, 2, 4. Again, you come to this 2. Is this 2 less than 4? Yes. Again, the same condition, no need to update, because in this case also you'll get the answer as 3 and so on, right? So here what we are doing, sorry, we are going to a particular index and we are saying that I am bound to include this particular element as the last element, right? We'll do the same thing here. We'll do the exactly same thing here. Now how that will work? I have some elements. Okay. Remember the number of words I have is 10 to the power 3. So even 10 to the power 3 into 10 to the power 3 will work, right? It's 10 to the power 6. So big of n square solution will work. Okay. What we'll do, I'll do the same thing for every index. Here the only thing is my condition will change. What will be the condition? The condition will be that suppose I come to this element. I'm saying what's the length of the longest increasing subsequence ending here. For that, I'll iterate the array for these positions. So when I come here, I just say, I'll just see that what are the conditions I want. If after this element, I want to take this element, their group ID should be different. Also, their Hamming distance should be equals to 1. So this is the only condition I need to add. And based on that, what I can do, I can simply keep on updating the answer. Now there is one extra thing I need to keep a track of. That extra thing is I also need to return the array, like what are the words you are selecting, right? So I just keep a track of previous index. Why previous index? Previous index will say that suppose I want to find the longest increasing subsequence ending here, right? And if after this element I am adding this element, so what I'll do, I'll say that previous index of this index is actually this one. So for it, if this is 0, this is 1, this is 2, this is 3. So for previous index of 3, I'll store 0. That means if I want to find the exact elements which is forming this longest increasing subsequence, I'll start from here. I'll say, okay, from here, what's the previous element? 0. Go to 0. Okay, from 0, what's the previous element? For that, I'll go to the previous index of 0. Okay, simple, basic thing. In this case, let's assume it's 0, 1, 2. Okay, and this is also 2. Let's skip it for now, right? So, or let's make it 1. Okay, so it says that if you want to find the longest increasing subsequence ending at 3, go to index 1. Okay, I go to index 1. Okay, if you want to find the longest increasing subsequence ending at 1, go to index 0. This should be -1, by the way. And I go here. So it says that 0, 1 and 3 are the indices which forms your answer. Simple. This will become clear in the code, right? So let's start. We'll do the exactly same thing I've explained you, right? This is the main function. These are n, this is the n, this is the number of words, this is the group, right? Now these are certain variables I have taken which are self-explanatory. Maximum length is the length of longest, what do you call it? Subsequence. Maximum end is also a variable that we have taken. We'll see why. This DP is the array which will store the length of longest increasing subsequence, and previous index is the same thing that I explained you, right? Now fill all the values with 1. Why? Because a single element is always forming a increasing subsequence, so no need to worry about that. Okay, now start from 0. I goes from 0 to n, meaning if I have n elements, one by one go and find what's the longest increasing subsequence ending at this index. Okay, previous index of this one is -1 because I don't know till now. This is the only single element for I that is forming increasing subsequence. Okay, now to find the answer, j goes from 0 to I, because if this is the last element, all the elements before it should be considered, right? I cannot consider elements after it. So that's why 0, it goes from 0 to -1. Now if group ID of I is not equals to group ID of j, and words of I dot length is equals to word dot j dot length, and Hamming distance of words of I is of I and j equals to 1. These are the 3 conditions that I want. If this is satisfied, then I just see key. If the new element, if dp of j plus 1 is greater than dp of I, that means whatever is my answer till now, okay, if that is less than the new answer that I am getting, then just update it, dp of I equals to dp of j plus 1 and previous index of I is equals to j. That means till this point, if you want to find the longest ingredient subsequence ending at I, so for I the previous index is j. When you go to j, you'll go to the previous index of j and you can simply backtrack, right? So this is the core logic, right? Now if dp of I is greater than max length, okay, so what do? You simply keep on updating that, okay, for all the elements I, what is the actual maximum increasing, what is the length of the increasing subsequence you can get, simple. Now time to find the final answer. So result, this is the array list that I've taken. Now this is a do while loop. Generally you do not see a do while loop, but I've taken here because I want this loop to run at least once. Why? Because if it's a single element, what will happen? Its previous index will be -1, right? So if I directly add while previous index is not equals to -1, that can make things complex. Simple thing is, I have to include at least one element. So result.add words of maximum end. Remember, maximum end is holding the index, last index of the subsequence, which has the maximum length, right? Then max end equals to previous index of max end. Backtracking. Okay. Now you keep on running this till your max end is not equals to -1. Now your answer is actually in reverse order. You just reverse it and return the answer, right? I hope this becomes easy. Last thing, what is Hamming distance function? It takes two words and it simply, you know, what do you call it? Compare the characters. If the distance, it returns the distance, right? So if the distance is equals to 1, it's valid. Obviously you can optimize this function as well, right? As soon as the distance becomes greater than 1, you simply return true or false, and a bunch of other things could be done. But yeah, this solution was relatively easy to understand. That is why I wrote the solution in this way. Okay. So yeah, we try to relate a very popular problem to this one so that you understand how to form relationship between these problems, right? So yeah, I hope you learned something new from this video. Please do support it by giving up thumbs up, do subscribe to the channel, and let me know if you face any issues related to the solution, and also let me know if you used any other approach to solve this problem. Mention that in the comment section so that we all can learn from each other. Okay, thank you, take care, bye bye.